Welcome back, Physics 30. We're going to look at part 2 of the acceleration booklets. So this deals with pages 88 to 92 of the booklet. And if we look at, we're going to distinguish between positive and negative acceleration, recognize situation in which we look at accelerations of 0, interpret velocity versus time graphs to determine the velocity of a specific instant in time, and also look at velocity time graphs to look at acceleration. Okay, so again, looking at uniform versus non-uniform acceleration. So uniform, so a change in velocity of some kind is an acceleration. So if it's a constant change in speed, that is uniform acceleration. If we're looking at velocity changing sporadically, that is considered non-uniform acceleration. Okay. 4 ways we can talk about uniform acceleration of 8 meters per second squared. Just by writing it out, 8 meters per second squared. So that means every second that passes by, the velocity is increasing by 8 meters per second. As an equation, we can look at it. 8 meters per second squared, change in v over change in t. We can look at a chart here. As the time increases by 1 second each time, our velocity increases by 8 meters per second every second. So as every second passes by, our velocity increases by 8. Or graphically, as each second passes by, you can see 8, 16, 24. It's an increasing straight line. That would be an acceleration as well. And of course, if we look at it, similarly with the position time graph, the slope gives velocity. With the velocity time graph, the slope gives acceleration. So the slope of a VT graph. So, of course, if we look at that, 3 possibilities. If it is, if we're moving in a positive direction, that's one assumption I say here. If we get a positive slope, that means the acceleration is working with us. If we're moving in the positive direction, and if we have a positive slope, that means we're speeding up in the direction we're going. If it's negative, it means we're slowing down in the direction we're going, so that's going to be deceleration. And of course, if it's a flat line, constant velocity or constant speed, that's going to mean 0 acceleration. Or of course, other scenarios if we're not moving, then that of course is 0 acceleration as well. Okay, number 5. You have a graph that looks something like this. I think yours looks a little neater. I've made a note of certain points here: 0, 0, 4, 40, 10, 80, and 15, 80, because they deal with some of the questions coming up. Excuse me. So, first of all, how fast is the car, or whatever, I guess it's a car, how fast the car moving during these times? Since it's a velocity time graph, just simply reading off the graph will tell us the velocity. So at 2 seconds, you can see I'm moving approximately 20, and I think the unit you have on your graph here is kilometers per hour, north. 4 seconds, 40 kilometers per hour north, and at 15 seconds, 80 kilometers per hour north. So that's just simply reading off the graph there. If it's a velocity time graph, finding velocities during certain times, you just read off the graph. Acceleration though, from 0 to 4, 4 to 10, 10 to 15. So 0 to 4, 4 to 10, 10 to 18, of course, this is going to give us the slope. So if we take a look here, V2 minus V1 over T2 minus T1. So 40 minus 0 over 4 minus 0. So that is going to give us 10 kilometers per hour per second north. Okay, so it's very fast. As every second passes by, our speed is changing by 10 kilometers per hour every second. So from 4 to 10 and 10 to 15. So from 4 to 10, so we're going to do 80 minus 40 over 10 minus 4. When you figure that out, I didn't show the work here, but you could. 6.7 kilometers per hour per second. Then lastly, going from 10 to 15. So that's from here to here. 80 minus 80 over 15 minus 10. So of course 80 minus 80 is going to give us 0. And you can see here, if time is passing by and if my velocity is staying the same, that means you're not speeding up, you're not slowing down, so you have 0 acceleration. Okay, number 6. Your graph looks something like this. Yours is likely a lot neater. So for each lettered section on the graph, calculate the acceleration. So letter A is from this dot to this dot. Notice what I did here. I marked down some key points. 0,7, 2,7, 6,1, etc. So from A, I'm looking for the starting point and the end point here. So 7 minus 7 over 2 minus 0. Of course, that's going to give you 0 there because we get. And you can see here, the velocity is staying the same, not changing. So of course, I'm not accelerating. So maybe pause the video right now and see if you can determine the values for B, C, D, and E there. Okay, if you had a chance to do that, B, 1 minus 7 over 6 minus 2. So of course we get a negative number because you can see it's decreasing slope. Negative 1.5 meters per second squared. So that means we were moving at a velocity of 7, and now we're decreasing by 1.5 meters per second every second that ticks by. Section C, of course, you can see that that's 0, and I guess that was the only question we had to do. We didn't have to figure out D and E according to this handout here. Okay, number 7. Construct a VT graph that looks like this. A car starts from rest and accelerates 8 kilometers per hour for 10 seconds. So what we can do here is we can say, okay, for every second, our speed changes by 8 kilometers. So after 1 second, you're going 8. After 2 seconds, 16. After 3 seconds, 24, etc. So as every second goes by, your velocity increases by 8 each time. So it looks something like that. Straight. It's constant acceleration, so it's a straight line that's increasing to the right. This one, runner who's running at a constant speed for 8 meters per second for 5 seconds, then slows down at a uniform rate. When you see uniform rate, that implies straight line, and stops in 2 seconds. So we could take a look at this. For the first 5 seconds, going at a constant velocity of 8, and then in the next 2 seconds slows down to 0. So that would just be a straight line decreasing down to 0. That's it. And then the last question here, it says directly on the VT graph below, so yours looks neater than mine, construct a line that has an acceleration that's 2 times greater than the original, half that of the original. Now on a VT graph, a velocity time graph, acceleration means slope. So when you see 2 times the acceleration, that's twice as much slope. So if I pick a point here, 4, 12.5, twice as much velocity is twice as much slope, so 25. Or half as much here. I went flower power here on you with this line. It's half of 12.5, so that's 6.25. So twice the slope, half the slope. Twice the acceleration, half the acceleration. So just sketch it, looks something like that. Okay, that is it for the assignment. We'll see you next time.